Hi everyone, and welcome to our lesson on maximum voltage of PV system circuits. My name is Roger Williams. I'm an instructor with Solar Energy International, as well as a curriculum developer. And a couple of reminders before we get started. If I'm talking too fast, remember you can slow me down. And if I'm talking too slow, by all means, speed me up. I sound brilliant that way. In this lesson, we're going to show you how to calculate PV module and circuit voltage based on the temperatures that those modules are experiencing. We're going to look at the different options to calculate maximum system voltage. And why do we do this? Well, we want to make sure our systems and components are compatible with the voltages they're going to see. So it all starts with the National Electrical Code and section 690.7, maximum voltage of PV system DC circuits. Now this is basically the highest expected DC voltage a PV system is going to see. What does that maximum voltage depend on? Basically these three things: the expected lowest temperature on site, the module specifications, right? There's thousands of different modules out there. They all have different voltages and a few other parameters. And then finally, the number of modules in series. Yeah, that's certainly going to affect our circuit voltage. Quick refresher, there we have our beloved IV curve, and we see, right, the highest voltage is that open circuit voltage in the lower right of the graph. We have these three things, right? The temperature, module specifications, and number of modules in series that we need to consider when calculating maximum voltage. Now, in circuits that have DC to DC converters, well, the maximum voltage is really just based on the manufacturer's rating or their instructions for use of their product. Now, why do we calculate maximum voltage? Well, we need to know the maximum voltage of the system because we're going to be choosing different types of conductors, all the equipment. There's also working space clearances and other voltage dependent requirements within the National Electrical Code that depend on the maximum voltage of a system. Section 690.7 provides us with some guidance for our maximum voltage limits. For 1 and 2 family dwellings, the maximum voltage is less than or equal to 600 volts DC. So this is basically our residential PV systems that we put on a client's home. 1 and 2 family dwellings is limited to 600 volts DC or below. For other roof-mounted systems, basically those that are not 1 or 2 family dwellings, we can have systems up to 1,000 volts, okay? 1,000 volts or less. This is what, our small commercial systems, we'll call them. This is systems you're putting on businesses or apartment buildings, that kind of thing. And then finally, we have systems that are not in or on buildings. Basically, ground-mounted systems, carports, systems where those first two designations do not apply. Now, there's really no specific limit. What we're basically limited by the available equipment that we have, right? Inverters, modules, wires, disconnects, all of that stuff. But Section 690.7 does say that these systems that are not in or on buildings that are less than or equal to 1,500 volts DC are not required to comply with parts 2 and 3 of Article 490. Article 490 is about systems and equipment above 1,000 volts. So 690.7 tells us ground-mounted systems that are less than or equal to 1,500 volts DC, we don't have to comply with parts 2 and 3 of Article 490. Here in our image, we see a type PV wire cable. We see the size is 10 AWG. We also see its voltage rating. It's 2 kV. Guess what, everyone? That's 2,000 volts. We want to know that rating for all of our equipment, right? Our modules, inverters, conductors, disconnects, everything has to be rated for the maximum voltage of our PV system. And we're going to calculate that following the rules in 690.7. And we're going to look at that in our part 2, where we show you how to calculate that voltage. Thanks everyone for joining me. Join me for part 2 when you're ready.